The nearest star is 4.2 light years away. The nearest galaxy is 2.5 million light years away. The edge of the universe is 46 billion light years away. You've memorized these numbers your whole life. Every single one of them is a lie. Leonard Susskind says distance in space doesn't exist the way you think. It's not real, it's not fixed, it's not even well defined, and the physics proving this will completely destroy your understanding of how big the universe actually is. Take a ruler. Measure the distance from your hand to your face. Let's say 30 centimeters. Simple, clear, definite. Now keep that ruler perfectly still. Don't move it. Just wait. Is the distance still 30 centimeters? You say yes. Obviously yes. The ruler didn't move, your hand didn't move, your face didn't move, the distance is still 30 centimeters. Leonard Susskind says you're wrong. The distance changed. It's different now than it was 10 seconds ago. Not because anything moved, but because space itself is expanding between every point in the universe and every other point, including your hand and your face. The expansion is tiny at small scales, unmeasurable with a ruler. But it's real. It's happening. Right now. The space between your hand and your face is slightly larger than it was when you started reading this sentence. Distance is not fixed. It's not a permanent property of space. It's dynamic, changing, flowing. And at cosmic scales, this fact becomes so extreme that the entire concept of distance falls apart completely. Let me show you how deep this rabbit hole goes. Start with something everyone knows. The universe is expanding. Discovered by Hubble in 1929. Galaxies are moving away from us. The farther away they are, the faster they recede. But here's what nobody tells you. The galaxies aren't moving through space. Space itself is expanding, carrying galaxies with it, like raisins in rising bread dough. The raisins aren't moving through the dough. The dough is expanding, pushing them apart. This distinction matters, because if galaxies were moving through space, there would be a maximum speed, the speed of light. Nothing can move through space faster than light. That's special relativity, fundamental law. But space itself can expand faster than light. In fact, it does, right now. Most of the observable universe is expanding away from us faster than light speed, not violating relativity, because nothing is moving through space. Space itself is growing. The observable universe has a radius of about 46 billion light years, but the universe is only 13.8 billion years old. Light has only had 13.8 billion years to travel. So how can we see things 46 billion light years away? Because those things were closer when they emitted the light. The light traveled toward us through expanding space. While it traveled, space expanded, carrying the source farther away. By the time the light reached us, the source was 46 billion light years away, even though the light only traveled for 13.8 billion years. Distance is not what you think. The distance to that galaxy is 46 billion light years now, but it was much less when the light left. And by the time you finish reading this sentence, it will be slightly more, because space is still expanding. What does distance even mean when it changes while you measure it? Susskind says this is the first hint that distance is not fundamental. It's not a property of reality. It's a coordinate, a way of labeling positions. But coordinates can be chosen arbitrarily. Different coordinate systems give different distances, and none of them is more real than any other. Now add special relativity. This is where it gets genuinely disturbing. In special relativity, different observers in different reference frames measure different distances. This is length contraction. A spaceship moving at high speed looks shorter in the direction of motion to someone watching it pass by. From inside the spaceship, nothing changed. The ship is the same length it always was, but from outside, watching it zoom past, it's contracted, compressed, shorter. Who's right? Both. That's the shocking part. Length is relative, not absolute. The distance between the front and back of the ship is different depending on who's measuring. And it gets worse. If you and I are moving relative to each other, we don't even agree on what simultaneous means. Events that happen at the same time for me happen at different times for you. Our nows are different. This means we don't agree on the distance between two events either, because distance in relativity is not just spatial, it's space-time distance. And space-time distance depends on your reference frame, your velocity, your acceleration. Two observers, same 2 points in space, completely different measured distance, both correct, neither more true than the other. Distance is observer-dependent, not a property of reality, a property of the observer's relationship to reality. Susskind emphasizes this constantly. Students resist it. They want distance to be real, to be out there in the universe, independent of measurement. But relativity says no. Distance is relational, not absolute. Now bring in general relativity, Einstein's theory of gravity, and distance becomes even less real. In general relativity, massive objects curve space-time. The curvature changes the geometry, changes what distance means. Near a black hole, space is so curved that normal geometry doesn't apply. The distance around the event horizon, circumference, divided by the distance through the center, diameter. You'd expect pi, 3.14159, circle geometry. But near a black hole, you don't get pi. You get something else, something larger, because space is curved. What does distance mean when circumference divided by diameter doesn't equal pi? When straight lines aren't straight? When the shortest path between 2 points curves? Distance becomes coordinate dependent. You can choose coordinates where the black hole is far away, or coordinates where it's close. Different coordinate systems, different distances, all equally valid, all describing the same physical reality. Susskind points out that general relativity doesn't even have a preferred way to measure distance. The metric tensor tells you how to measure, but you have to choose a metric first. And that choice is arbitrary, conventional, not determined by physics. Physicists use different metrics for different problems. Schwarzschild coordinates for non-rotating black holes, Kerr coordinates for rotating black holes, Eddington-Finkelstein coordinates to study horizons. Each gives different distance measurements, all correct. Distance is not a fact about the universe, it's a choice about how to describe the universe. Now here's where your brain should start melting, because we're about to go deeper. The holographic principle, Susskind's big contribution to physics, says that all the information in a volume of space is encoded on the boundary of that volume, on the surface, a sphere containing a galaxy, all the information about everything in that sphere, every star, every planet, every atom, every quantum state, is encoded on the two-dimensional surface of the sphere, not in the three-dimensional volume. The 3D interior is redundant. It's a holographic projection from the 2D surface, like a hologram on a credit card, looks 3D, but all the information is actually on a flat surface, encoded in interference patterns. If this is true, if the holographic principle is correct, then the distance between 2 points inside the volume is not fundamental. It's emergent. It arises from information on the boundary, but it's not really there in any deep sense. Two galaxies separated by billions of light years. That separation is an illusion, a holographic projection. The real information describing both galaxies is on the same surface, the cosmic horizon, the boundary of the observable universe. The distance between the galaxies is like the distance between two images on a TV screen. Looks real, looks like separation, but actually both images are coming from the same screen, the same surface. The separation is in the projection, not in the source. Susskind has spent decades developing this. ADS-CFT correspondence. Anti-de Sitter space in 5 dimensions is exactly equivalent to conformal field theory on the 4-dimensional boundary. Gravity in the bulk emerges from quantum mechanics on the boundary. Distances in the bulk are not fundamental. They're derived from entanglement structure on the boundary. 2 points far apart in the bulk correspond to weakly entangled degrees of freedom on the boundary. 2 points close together correspond to strongly entangled degrees of freedom. Distance is entanglement. Separation is correlation. Proximity is quantum connection. The geometry of space emerges from the information structure of the boundary. This is ER equals EPR. Einstein-Rosen bridges equal Einstein-Podolsky-Rosen entanglement. Wormholes equal quantum entanglement. Two entangled particles are connected by a microscopic wormhole, a geometric connection. But which is more fundamental, the wormhole or the entanglement? Susskind says entanglement. The wormhole is the geometric description of entanglement. The distance through the wormhole emerges from the entanglement structure. Distance is derivative. Quantum information is primary. Now think about what this means. Every measurement of distance you've ever made, every ruler, every tape measure, every GPS calculation, all of it is measuring something that's not actually there. You're measuring emergent geometric properties of underlying quantum information. The meter stick in your drawer. When it measures 1 meter, it's not measuring real distance. It's measuring the correlation structure between quantum degrees of freedom at the two ends of the stick. The distance is how that correlation appears in the emergent macroscopic description. Distance is real the way temperature is real. Temperature exists. You can measure it. It affects things. But it's not fundamental. It's average kinetic energy of molecules. It emerges from microscopic physics. Distance is the same. It exists. You can measure it. It affects things. But it's not fundamental. It's emergent geometric description of quantum entanglement. It arises from microscopic information structure. Susskind pushes this even further. In quantum mechanics, you can't measure position and momentum simultaneously with perfect precision. Heisenberg uncertainty principle. The more precisely you know where something is, the less precisely you know how fast it's moving. This means distance is fundamentally uncertain, fuzzy, indefinite at quantum scales. You cannot say exactly where something is, cannot measure exact distance. The universe forbids it. At the Planck scale, 10 Sardenwaldsat 35 meters. Quantum fluctuations of spacetime itself become significant, virtual particles popping in and out of existence. Quantum foam, spacetime stops being smooth, becomes granular, chaotic. At this scale, distance doesn't exist in any meaningful sense. You can't point to two locations and say they're exactly X meters apart. Space itself is fluctuating, uncertain, indefinite. Distance is an approximation, valid at large scales, breaking down at small scales, like how water looks like continuous fluid at human scales but becomes discrete molecules at small scales. Distance looks continuous and real at human scales but becomes meaningless quantum foam at Planck scales. Now we're going to a place that will genuinely disturb you, because once you see this, you can't unsee it. Dark energy, the cosmological constant, the thing causing the universe's expansion to accelerate, making galaxies fly apart faster and faster. Current measurements say 68% of the universe's energy is dark energy. It's everywhere, uniformly distributed through all of space. And it has a bizarre property. As space expands, the density of dark energy stays constant. Normal matter and energy dilute as space expands. Double the volume, half the density. But dark energy doesn't dilute. Double the volume, dark energy doubles too. The density stays fixed. This means dark energy is a property of space itself, not stuff in space. But space, empty vacuum, has energy, and that vacuum energy is what we call dark energy. As the universe expands, more space is created, and each new cubic meter of space comes with its share of dark energy. The total dark energy in the universe increases as space expands. Now here's the thing that should terrify you. This expansion is accelerating. Galaxies are getting farther apart faster and faster, and this acceleration will never stop. It will continue forever, exponentially. In the far future, billions of years from now, distant galaxies will recede so fast that light from them can never reach us. They will cross the cosmic horizon, the boundary beyond which light cannot catch up with expansion. Once a galaxy crosses the horizon, it's gone. Forever. Not just invisible, causally disconnected. Nothing that happens there can ever affect us. Nothing we do can ever affect them. It's as if they're in a different universe. The observable universe is shrinking. In terms of what we can see, what we can interact with, what we can know, right now we can see objects 46 billion light years away. In the future, that number will be smaller, and smaller, and smaller. Eventually, only our local group of galaxies will remain observable. Everything else will be beyond the horizon, unreachable. The universe will look empty, dark, isolated. What does distance mean in this context? The distance to a galaxy beyond the horizon is infinite, operationally, causally. The galaxy is infinitely far away because you can never reach it, never interact with it, never receive information from it. But physically, the galaxy still exists. It's at some finite coordinate, some finite number of light years away. The distance is both finite and infinite, depending on how you define it. Susskind says this reveals that distance is not well defined at cosmic scales. You have to specify what you mean. Coordinate distance, proper distance, luminosity distance, angular diameter distance, each gives different answers, and none is more correct than the others. Now add quantum mechanics to expanding space, and things get truly bizarre. Quantum field theory in curved spacetime. This is Susskind's specialty. The vacuum in expanding space is not the same as the vacuum in flat space. Particle creation happens spontaneously. The Unruh effect. An accelerating observer sees thermal radiation where an inertial observer sees vacuum. The acceleration creates particles from nothing, from the quantum vacuum. Similarly, expanding space creates particles. The expansion accelerates local reference frames. This acceleration produces radiation, real particles appearing from vacuum. Hawking radiation from cosmological horizons works this way. These particles appear in pairs, one inside the horizon, one outside. The two particles are entangled, quantum mechanically connected, but they can never interact, never meet, never causally communicate. The distance between these particles is zero in one sense. They're entangled, quantum mechanically one system, no separation at the information level. But the distance is infinite in another sense. They're on opposite sides of an event horizon, can never meet, causally disconnected. Zero and infinite simultaneously. Distance has no meaning for entangled particles separated by event horizons. Susskind's EPR makes this explicit. The two particles are connected by a wormhole, an Einstein-Rosen bridge. The wormhole is the geometric manifestation of their entanglement. The distance through the wormhole is tiny, microscopic, but the distance around through normal space is infinite. Same 2 points, two completely different distances, both correct, both real, both descriptions of the same physical situation. Distance is context-dependent, geometry-dependent, observer-dependent, not a fact, not a property of reality, a description, a representation, a way of organizing information about relationships. Now let's talk about something most physicists don't like to admit. We don't know what distance is, fundamentally. We can measure it, we can calculate with it, we have equations for it, but we don't know what it is. Is distance something physical, or is it just a mathematical construct, a coordinate in our theories, a useful fiction? Susskind leans toward the latter. Distance is a way of describing relationships between quantum systems. It emerges from entanglement structure, from information geometry. It's real in the emergent macroscopic world, but not fundamental, not built into the bedrock of reality. This connects to his work on black hole complementarity, the information paradox. When something falls into a black hole, does it go inside, or does it stay on the horizon? Susskind says both. From an outside observer's perspective, the object never crosses the horizon. It freezes. Its information spreads across the horizon's surface, encoded holographically. From the infalling observer's perspective, the object crosses smoothly, falls to the singularity, experiences the interior. Both descriptions are correct, both are physically real, but they disagree about distance. In one description, the object is at the horizon, surface distance 0. In the other description, the object is at the singularity, inside the black hole. Finite distance from horizon. Same object, same black hole. Two different distances, both right. Distance is not absolute, not determined by physics, only by perspective. This is complementarity. Different observers see different but compatible descriptions of the same reality. Distance is one of the things that differs between descriptions. Now, the philosophical implications. If distance is not real, not fundamental, what does this mean for our understanding of the universe? It means the universe is not a big empty container with things in it separated by distances. That picture is wrong, misleading, a simplification. The universe is an information structure, a quantum state in Hilbert space, evolving according to Schrödinger equation. Distance is how this information structure looks when projected into three-dimensional space. But the projection is not the reality. The reality is quantum information. Entanglement patterns, correlation structures, distance emerges when you coarse grain, when you average over microscopic degrees of freedom, when you look at large scales. This is why quantum gravity is so hard. People are trying to quantize space, quantize distance, quantize geometry. But these things are already emergent from quantum mechanics. You can't quantize what's already quantum. You have to find the underlying quantum degrees of freedom, the information structure that creates the illusion of distance. Susskind's holography does this. The boundary degrees of freedom are quantum. The bulk geometry, including distance, emerges from their entanglement. Distance is not quantized. It's derived from quantum information. This also explains why there's no experiment that can measure the exact distance between 2 points at Planck scales. Not because we don't have good enough technology, because the question is meaningless. Distance doesn't exist at that scale. Only quantum information exists. Now let's go full existential. What does this mean for you, for your experience of the world? You experience distance constantly. You walk across a room, you drive to work, you think about someone far away. Distance feels real, fundamental, undeniable. But according to Susskind's physics, all of that is emergent. The distance from here to there is a macroscopic approximation of quantum entanglement structure. The separation you experience is a projection of information geometry. You and the person far away are not actually separated by miles. You're quantum systems with low entanglement, weakly correlated. That weak correlation manifests macroscopically as distance, as separation, as being in different places. If you were maximally entangled with that person, if your quantum states were perfectly correlated, you would be the same system. No distance, no separation. One entity distributed across two locations, which is how entangled particles work. They're not two things far apart. They're one thing in two places. This is not metaphor, not poetry. This is what the mathematics says. Entanglement is geometric, creates connections, wormholes, bridges. Distance is the absence of entanglement. Separation is decorrelation. Susskind sometimes asks students a disturbing question. Are you sure you're in your body? Are you sure your consciousness is located where you think it is? Because location requires distance, and distance is emergent. Your consciousness is a pattern of information. That pattern exists in the structure of quantum correlations in your brain. But the quantum correlations are not in space. Space emerges from them. Your consciousness might not be located anywhere in any fundamental sense. It's a pattern in information space. And information space doesn't have distances, only correlations. Where are you? Nowhere, and everywhere. And the question might be wrong. Now the final twist, the one that brings all of this together. The universe is a hologram. Space is emergent. Distance is fake. What's real? What's actually there when you strip away the emergent descriptions? Quantum information, qubits, entanglement, that's it. That's the fundamental reality. Everything else is how that information organizes itself, how it looks when you coarse grain, how it manifests at macroscopic scales. You are not a body in space. You are a pattern of quantum information that creates the experience of being a body in space. The space is emergent. The body is emergent. The distance between your body and other bodies is emergent. What's real is the information, the quantum correlations, the entanglement structure. Everything else is projection, appearance, useful fiction. Leonard Susskind has spent 50 years discovering this. Slowly, piece by piece, holography, ADS, CFT, ER, EPR, black hole complementarity, all pointing to the same truth. Distance is not fundamental. Space is not fundamental. Geometry is not fundamental. Only information is fundamental. Only quantum mechanics is fundamental. Everything else emerges. This is the shocking truth about distance in space. It's fake, not in the sense of being wrong or illusory, but in the sense of being derived, emergent, secondary, a useful macroscopic description of deeper quantum reality. When you measure a distance, you're not measuring something that exists independently. You're measuring how quantum information is organized. You're reading off correlation structure. You're seeing emergent geometry. The universe doesn't have distances. It has quantum states. The distances you experience are shadows, projections, the way quantum correlations look from inside the system. Welcome to the holographic universe, where distance is emergent, where space is information geometry, where separation is decorrelation, where being close means being entangled, where the entire 3D world is a projection from quantum information on distant boundaries. This is not science fiction. This is modern physics. This is what the equations say when you follow them honestly, when you take quantum mechanics and general relativity seriously, when you demand consistency, when you look at what black holes actually teach us. Distance in space is fake, and now you know why, and you can never see a ruler the same way again.